Okay, so for this new semester, here's some tips on what I would expect. If you want to be an A student this semester, if you want to be one of those top students, you absolutely can be. Do you get that even though you had a B minus last semester, and I know some of you did, I looked, not only I taught some of you, but I looked at my new kids. I already creeped on you. I went under academic history and I can find out everything. I can even know what you tested in second grade, but I usually don't mess with that. I look at last year or this last semester. And so I want to get a feeling for my kids ahead of time. So I know some of you may have gotten B minuses last semester. Some of you I know are straight A students in my class. But if no matter what you had, you have nothing right now. Even if you had an A before, that just means you got really good momentum coming into this. But it's all about what happens now. If you had a B minus going, you have a new semester. It's kind of cool. It's all fresh and new. You can get a straight A again if you had one before. Or if you had a B minus, there is no reason you can't have an A this semester. You have some of you who have a new teacher, and you all have a new opportunity. And I strongly encourage you to take advantage of the chance to get a high grade. You will never look back and say, oh, I got too high a grades last year. But sometimes you will look back and go, crap, I got a B in a class where I could have easily had an A with a little extra effort. And your GPA suffers accordingly because you really want as high a GPA as you can as you move into college. Not just to get into college, but also to get better scholarships when you go there. It makes a difference. So all I'm saying is try for the A. And some of you will try for the A and get the B, and that'll be okay. But some people are just so used to B's, they're like, yeah, I kind of get B's in math. If you just set that as your expectation, you're not going to get an A. You have to say, I'm going to go for the A. And some of you might surprise yourself. All right. So you get your iPad out right away. And once you've got the code, which we already gave you for this class, it's dependent on the hour. If you're looking at this video because you missed today, my hours 2, 3, 4, and 5 have those codes that you see in green there. All right. But if you would have Schoology out every single day when you get into class, that would be awesome. That would be a good start. Apparently know how to spell no. Know that homework goes in your grade. If you didn't have me before, you may not have had to have your homework done. I do require your homework to be done, and I put it in your grade. Now, do I correct it every day? No. I try to do it in the neighborhood of every other time, but I don't do it every other time because kids will go, oh yeah, today is a Tuesday. He already graded on Monday, so I don't have to do tonight's homework. I grade it kind of randomly, and I don't grade it every single day just because it takes some time. But just to get you in the habit of it, I probably will grade tomorrow just to get you off on the right foot. So make sure you get your homework done. I know the answer key is posted. That's okay. It doesn't mean that you shouldn't use it. You absolutely could use it, because if I have two kids sitting side by side and one of them checked their homework and one didn't, one of them knows whether they're doing it right, and that's a big advantage. And it's smart to check it. Nothing wrong with that. Just don't copy it. Learn from it. All right. Just be respectful. I'm not going to talk about what you can and can't do in class. You pretty much know those rules. Just be respectful. I'll be respectful to you. If you're absent, please do go to Schoology for the notes and the videos. And I just talked to you about where this video is located. It's servervideo.com. Easiest way to get there. And remember to spell my name S-U-R-V-E-R, not S-E-R. Common oops. And last, I am available on Tuesdays, Wednesdays. I actually changed that. I apologize. It's Mondays. This is an old smartboard. Mondays, Wednesdays during Mass, and Thursdays also. So Mondays and Thursdays are normal days, and on Wednesdays you can see me during Mass time. So that's 3 days a week in the morning, and after school, almost every day after school, I'm available until 3. You just got to come in pretty quick. Get here by 2:45 so I know somebody wants my help. If so, I can hang around with you till 3. All right. The trigonometric ratios. Those are sine, cosine, and tangent. You've probably heard of them. Raise your hand if that sounds familiar. All right, good. Next, I need you to actually know what sine is. There's sine, there's cosine, and there's tangent. And I hope you have this memorized. So, ka, what? Toa. And it really helps you to remember them. But you need to know what O is, and what H is, and what A is. And so, O is opposite in the sides of a triangle from this angle's perspective. And notice there's so much to learn here. We're using right triangles only to start with. yes, by the end of this class, you'll be able to do trig without right triangles. You'll be able to find like the sine of 173 degrees instead of just the sine of 30s and 60s and 90s that go nicely in right triangles. But this is the standard angle sign. It's a theta. Get used to it. We're going to see it a lot. We never say x is the angle. We always say theta. An unknown angle is called theta. All right, it's just kind of a standard, just like m is usually used for what in math? Slope, good. What's pi usually used for? Pi isn't just pi. Pi is just a variable, but we use it for what? 3.14, okay? The magic number for circles. All right, so, S-O-H, opposite over what? Hypotenuse. So go ahead and write that. OPP over HYP would be a good abbreviation. Opposite over hypotenuse. What is cosine? What's that A in Ka? Adjacent. ADJ is a good abbreviation. Over hype. And the last one is the only one that doesn't have hype in it. Tangent is not overhyped. TOA. Opposite and adjacent. Just knowing those things sets you at an advantage to some kids, because some kids don't actually know them. And for them, this is all new, and this is going to go really fast because we kind of assume you've had this before, and most of you have. So, all right, so opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. I want to really quickly get into when would you ever need this? Well, for an example, let's say you have a right triangle. It's going to be a jump because you want to make a jump in your driveway for your little brother. He wants to jump over some cars that he's got placed out, and he wants to ride his bike over this thing, jump off of it, and then land after the cars. Okay, let's say that they're small cars. We're not like talking like actual size cars, but let's say that he's got a piece of wood that'll work perfect for this part right here. He's got the ramp part, okay, and it's 3 feet long. So write a 3 there. He's read that it's pretty tough to go at a super steep angle when you're riding your bike and all of a sudden go up something really steep. So he decides to make this 30 degrees right here. And he wants you to help him figure out how long the other pieces should be. Like, how long should this be? Let's call it x, this distance here. And then the height of the ramp. So what would you use? Well, sine, cosine, tangent. That's what this is for. Notice we only have one angle and one side, although I kind of lied. What do we have that I haven't said we have? A 90-degree angle. And therefore, instantly, I can have the third angle because what do you know about triangles? Add up to 180. So therefore, what's the last one got to be? That one's got to be 60. Everybody put that in. So really quickly, knowing one angle turns into knowing all the angles. Because if you're in a right triangle, you'll pretty quickly be able to figure out the other two. All right. And then I can use trig to figure out these other sides. Should I use sine, cosine, or tangent? Well, it kind of depends. Do you want to use the 30 or the 60? It really is just you get to pick. So what do you want to use? I'm going to use the 30 because it's closer to me. Here it is. I'm going to use that one. I could have picked the 60. It would have been fine. So if I'm going to use 30, then should I use sine of 30, cosine of 30, or tangent of 30? They would all have an equation, but only one of them would give me the right answer. What do you think? Sine, cosine, or tangent? Why? You have the adjacent and the hypotenuse. And if you go that, you go, is that sa? No, that's ka. So you're right. I have adjacent hypotenuse. I'm going to use cosine. I'm going to use that one right there. And cosine is adjacent over hypotenuse. I'm going to write that in. This is how you do it when you're just starting. Once you're good at this, you wouldn't need to write in adjacent and hypotenuse. But you're just starting, so why not? Then adjacent actually is got a name. In this triangle, adjacent to the 30 is this guy. That guy's adjacent, so it's x. Over the hypotenuse is something too. It's what? 3. So cosine of 30 is x over 3. And pretty quickly, I've got an equation. And now to clear my equation so it doesn't have fractions, I'm going to multiply both sides by what? By 3. And watch, all of a sudden, this is giving me an answer if I knew what cosine of 30 is. And I'll multiply by 3 here and by 3 here. It's 3 times cosine of 30. But you know what cosine of 30 is, because I hope you have memorized the classic 30, 60, 90 triangle ratios. Do you remember it? It's got a 1 in it. If you haven't got these down, you'll need to have them down just as much as you knew Suka Soka Toa, right? These have to just flow right off your tongue. This is the 1, 2, square root of 3. And where do they go? The 1 is obviously the smallest of 1, 2, and square root of 3. So you put the 1 there. 2, it's got to be twice as big as 1, right? Which of these sides is the biggest one of them all? The hypotenuse, and therefore that's the 2. And the other one is in between size, and it's as easy as 1, 2, 3, except that's not a 3, it's a square root of 3. And how could I have known that? Because a squared plus b squared equals c squared, right? Would you agree that 1 squared plus that squared is supposed to equal that squared? I want you to just ponder that for a moment and see if they actually do. 1 squared is 1, right? Plus, what is the square root of 3 but squared? 3 equals 2 squared, which is 4. Hey, it works. Cool. So 1, 2 square root of 3 is a biggie. Got to have that one down. So even when I move it and make it look different, like, oh, now the pointy end's over there. 30, 60, 90. I know that's not probably drawn perfectly proportionally, but you got to go, okay, well, if you say that's a 30, 60, 90, that's got to be 1, that's got to be 2, that's got to be square root of 3. You always try to do it in the order of 1, 2, root 3. All right, so here's one. Label it, please. Draw it at that orientation, and if I tell you it's a 30, 60, 90, you should be able to tell which one's got to be 30 because it's smaller than the other ones. I know it's not drawn perfectly, but you aren't going to find things drawn perfectly. Even the ACT test, which is $1 million test, they spend at least $1 million developing the questions for the ACT. There's only 60 math questions, and they'll spend $1 million developing them. Even they say that their drawings aren't perfect. So don't expect them. But if they label it and they say it's a 30, 60, 90, well then this would have to be 30. That'd have to be 60. That'd have to be 90. This would have to be a 1. What's the other one? 2. And what's this one? Square root of 3. Does this actually look like 1 and 2 proportionally? No, but you'd have to trust, even if the diagram's off, that it's got to be a 1, 2, and a root 3. In the ideal world, you'd actually draw it properly such that it looks like this is 1 and this is 2, and that's square root of 3. But just don't trust your drawings. You can trust the numbers that are on the drawings. Okay, so I'm going to leave this up for just a second and say, if you see this, you should be able to say what sine of 30, sine of 60, cosine of 30, cosine of 60, and tangent of 30 and tangent of 60 are. Just from having that picture, I should be able to slap tangent of 60 down, and you should be able to go, oh yeah, that's this over this. So I'd like you to figure out for me everything. Figure out sine of 30, cosine of 30, sine of 60, cosine of 60, and tangent of 30 and tangent of 60. Notice we never do tangent of 90. You'll learn how to do that in this course, but you don't know how to do it with right triangles. You can do tangent of 90, sine of 90. So tangent of 60, for instance, TOA, opposite over adjacent, would be from the 60's perspective, tangent opposite square root of 3 over adjacent 1. Did you get the tangent of 60 was root 3? Yes or no? Maybe I made a mistake. Did anybody get the same thing as me? That's right. Okay, I gave you a bunch to find, but now I'm gonna give you specifics. Find for me cosine of 30. And in a moment, I'm gonna call on a random person. I don't always go with hands. If I ask a really tough question, I'll often go with hands because I know only a few people might know it. But I often will do random person because I want you all to do it. And I don't want you to think, well, I'll just let some smart kid raise their hand and I'll drift off here. Everybody find cosine of 30. One of the other things, if I do have the dice call on you, and I know there's a few people whose IEP says that don't call on the kid randomly, okay? And if you're that kid, remind me of that. I do know of one person already that I would fake it if the dice came to them. I'd say, oh, it was the kid behind you. So anyway, but almost everybody in here does not have that in their special learning plan. So row 4, person 3, that would be you, Miss M. What did you say cosine of 30 was? Cosine is adjacent over ka, right? Hypotenuse. What's adjacent to the 30? The 30 is here, the adjacent one is there, and the hypotenuse is there, and you were so right. Root 3 over 2. Raise your hand if you would have had that one right if I'd have called on you. Okay, good. Let's call on another random person for a different one. Let's do tangent of 60. Tangent of 60. Notice we haven't used our calculator to do one of these yet. Could you? Sure. I'll actually have you use your calculator in a minute, but for right now, tangent of 60 can be done in your head. Row 4, last person. Explain how you got it. Okay, and what's opposite? Opposite from the 60 is root 3, I agree, over adjacent is 1. Root 3 over 1. Raise your hand if you had that one right. Okay, cool. So now back to where we were. Here's a problem, and we had said, actually, where were we? This one. 3 times cosine of 30 was our answer. Well, now we can do cosine of 30, right? I'd just make that little triangle quick and say, oh, it's 30, 60 triangle. 30, 60, 1, 2, square root of 3. You are going to draw so many triangles over the next few weeks. It's just ridiculous. You're going to have drawn, I bet you each kid will have drawn over 100 triangles on your own over the next 3 weeks. Easily. All right, because you keep drawing these kinds of things to figure out stuff like cosine of 30. Cosine of 30 is adjacent over hypotenuse. Do you get how I think cosine of 30 is root 3 over 2? So then this is 3 times that. 3 times cosine of 30, and cosine of 30 is root 3 over 2. So would you agree that it's, I'll put a 1 underneath this, 3 root 3 over 2? Okay. Now let's see what that is as a decimal. Everybody grab your calculator. When I have you type in cosine of 30, half of you are going to get it wrong. Explain. If you were the teacher and everybody types in cosine 30, are some kids just idiots? No. They all know how to type in cosine 30, but they get different answers. Why? Different modes. Yes, everybody check your mode. See if you're in degree mode or radian mode. Because you know what the calculator defaults to? Radian mode. That's what it'll be in under factory settings, or when you wipe your calculator, it goes back to radians. What does that tell you about the makers? They didn't just do that by accident. They think that radian mode's really handy. You know what I'm saying? And yet you don't even know what a radian is. So you'll learn that, and you'll start eventually, when you get smart enough that your calculator is usually in radian mode, you know you've gotten there. You've gotten to calculus level. Okay, so that's next year. Next year, they're going to encourage you to always have a calculator in radian mode. You don't even know what radian is. You got to get somewhere between now and then, right? Okay, so start with, be in degree mode, because I know you're used to that. And what is cosine of 30 degrees? Well, it's some decimal. It's the same as root 3 over 2. And then times it by 3. And then I'd like you to compare your answer with the kid sitting next to you. If you're different answers, just double check what they typed, because you should still see it on the screen. I'm going to pause for a second while you get that straight. Okay, so this one comes up at 2.59 if you were doing it correctly. And I think this gets you through the basics of what you kind of already knew, right? I hope you knew this before at some point. How many of you feel like you've learned this before? Okay, good. If this is brand new to you, you should talk to me after class. I can give you some more stuff that you can do to get caught up, because for most people, this is review day. We're going to obviously move on and learn a lot more stuff later. Today, I have one more thing for you, and that's about degrees, minutes, and seconds. The Greeks are the ones who picked that there would be 360 degrees in a circle. That wasn't like law. That wasn't like something that had to be. Couldn't the degrees have just been bigger, and there could have been like 100 degrees in a circle? Yes, they could have picked anything. But they picked 60s because they were kind of obsessed with 60s because it's a really cool number. They didn't have calculators, and it was really nice if things divided into each other. You know, like 8 divided by 3 doesn't work out nice, right? Not near as nice as 8 divided by 4 or 8 divided by 2. Well, 60 has a special property. 1 goes into 60. Well, that's no big deal. 1 goes into everything, right? But 2 goes into 60. 3 goes into 60. 4 goes into 60. 5 goes into 60. And 6 goes into 60. Name another number that has all of those things. Well, 120. But it's based on 60, right? So anyway, 60 is really cool because it's very, very divisible by things. So where do you think they got the 360 from? 6 sets of 60. And once you've decided how big an angle, a degree is, they actually, if you need to know how big a degree is, you could draw yourself a circle and then cut it in half, and now you know what 180 looks like. Well, kind of like a straight line, right? And then cut it in half again, and now you got a 90, right? And then cut it in half again, each of the spots, and now you got 45-degree angles. And you can get it down to 1 degree if you want to know exactly how big a degree is. All right. So everything's divisible really nicely based on 60s. So this next thing, degrees, minutes, and seconds, if I said, what's between 45 degrees and 46 degrees? Well, you might say like 45.3 degrees. Yeah, but they didn't use decimals back then. I'm not saying that they didn't know about decimals. I'm saying that they like things in fraction form, and since they're obsessed with 60s, it wasn't too big of a surprise that they would say that the next part, if they wanted to add something to this, 45 plus a little bit more, would be a certain number of 60ths. And therefore, our time is also based on 60. Did you ever notice that? 60 seconds in a, what, minute, and 60 minutes in a hour, and there's a lot of 60s in there, and that's also because it's divisible, blah, blah, blah. So anyway, they did this kind of related to time. Like if I say 45 degrees for somethings, what do you think I'm going to say next? Minutes. I saw some people mouthing it. Minutes is correct, and there's a little one single dash for that. And let's say 23 seconds, that would be a double dash. Now, what does that really mean? Well, it's a little bigger than 45, but less than 46 degrees. It's 45 point something. It's 45 plus 4. Come on, you can do this. It makes sense based on everything I just told you. 60ths. Plus 23. Not 60ths. That would be dumb. We already have 60ths. 3/60ths, because that's 60 times 60, and that's how many seconds are in an hour. 60 times 60. I'm going to keep the 60 theme going. Yes, it is 360. 3,600, actually. 36 plus a couple zeros. 360 with a 0. Anyway, there's how they did their decimals. Now, couldn't we also say there is such a thing as 45.137 degrees? Yes, you can use decimals. And then there's a fancy neato button on your calculator that will change that to degrees and minutes and seconds for you. it's kind of, shortcut is pretty logical. Since it's degrees, minutes, and seconds, it's DMS. So where the heck is the DMS button to change that into degrees, minutes, and seconds? No, it's not DMX. That's a completely different thing. DMS. Everybody look on your calculator for the apps button. It is not an app, but it's above the apps button. Hit second apps and you'll be in the angle menu. Once you're in the angle menu, do you see DMS? So everybody try to change 45.137 by hitting 45.137 DMS. Again, I said it was above apps, and that's the angle menu. Once you're in the angle menu, you're looking for DMS. Now, would you again compare with the kid next to you, just because I want you to see that they've got it. Some people try to hide that they don't know where they are, and we need to smoke them out and make sure we know who's lost and get them help. If they can't find it, help them. I'll pause for a second while you do. So here we go. When you typed 45.137 and then you hit DMS, what did you get, sir? 5 degrees, 8 minutes, and 13.2 seconds. And it wasn't it funny that they had their still revert to a decimal at the end? Okay, so yeah, but here, let's just do a simple one. How about this? What if it was 45.5? Don't use your calculator. Think. What should that be? It's got to be 45 degrees and some seconds, right? Or minutes or something. If it's half of a degree, do you get how many minutes that should be? Some number of minutes out of 60, right? And so that's going to be 30, and that's therefore 30 minutes. How many of you would have had that one right? Okay, good. Let's try another one. It's fairly simple. "45 degrees and 6 minutes." Sorry, not seconds. 6 minutes. What's that the same as a decimal? Write this down. You will not learn anything by staring at the screen. Would you agree that's the same as 45 degrees plus, we're always making a little bigger, right? 6 out of 60, which does that reduce? What is 6/60? The same as 1/10. So 45 degrees and 1/10. Isn't that the same as 45.1 degrees? All right, check it. Use your DMS button on your calculator. Type in 45.1 degrees, hit DMS, see if it works. Excellent. Did you get 45 degrees and 6 minutes? All right, I think you're getting the idea. So that's degrees, minutes, and seconds. So now that's really the only new thing that you had for today. Now let's get to the homework. In a moment, my alarm is going to go off on my phone. And it's not me getting a phone call. It's for those of you that are new to my class, it's a 12-minute warning. It's telling me that, hey, bozo, wrap it up, because we want them to have at least 10 minutes left in class. Why? Because I want you to always have some time to work. It's my commitment to you to try to always give you 10 minutes of time in class to be able to work. And it also gives you time to come up and ask me questions individually and ask me like, hey, can you not seat me next to Will because he's been picking on me since 4th grade. He's kind of vicious. All right, so here we go. Our homework looks like this. There's homework on it. There it is, assignment actually. Now, this very first problem is messed up. I will save you the time of finding it, but it says that C is 30. Look, if I put a 30 here, does that look like it's 30? What should really be there? 60. Let's change that 30 to a 60 because that's much more logical for the picture. Granted, the picture is not to scale, and that's what it'll say on the ACT, but I don't want your very first problem to be messing with your head that the angles are all off. Okay, so that one's 60, and obviously that leads us to believe that angle A right here should be what? 30. And isn't that a common triangle, the 30, 60, 90? I hope you know that right off the bat. And you go, oh, so you're saying, Mr. Server, that that's got to be 1, that's got to be 2, and that's got to be root 3. There's that 12-minute warning. But I'm already starting your homework with you, so that's a good sign. Okay, so, but is it actually 1, 2, and root 3? No. It's actually, A is 2.3. It says that right there, so I'm going to change this to 2.3. But the cool thing is, do you get, it'll still keep the same ratios as that? It's not 1, it's actually 2.3. But think of it this way. It's 2.3 times bigger than the original triangle. And so therefore, everything's 2.3 times bigger than its original. Do you get what I'm saying? This has got to be 2 times 2.3, which makes it 4.6. Could you have done it with trig? Absolutely, but I just did it with trig. I just didn't use a calculator. I just used logic that, hey, compared to the original 1, 2, 3 triangle, this one says it's 2.3 over there. Therefore, this other side has to be twice that big. 2 times 2.3. Now, could I have done it with trig? Absolutely, and I hope that you can. So, for instance, to find B, I could have said that this angle right there is 60, right? I could have said cosine of 60 is adjacent, which one's adjacent to it? Oh, yeah, this one. That's adjacent to the 60. It's 2.3 over the hypotenuse, which is B. That's an equation you could have solved. And once you're all done with it, it turns out cosine of 60 is a half. How would I know that? Because I go off to the side, make my little 30, 60, 90 triangle. You're going to do this so often. And you go, okay, let me think. The cosine of 60 is adjacent over hypotenuse. That's adjacent, that's hypotenuse, so it's 1/2. Oh, cosine of 60 is 1/2. And then you can get the 2.3 alone, and you end up having to go B equals 2.3 times 2, which is 4.6, what I told you before. I just showed you 2 ways you could do it. I don't care which way you use. If you're better at the angle ratios, do it that way. If you're better with using trig equations like sine of 45 equals 2 over x, those kind of equations are awesome too. But anytime it says like sine over 45, you have to be able to go off to the side. Do you know this one? 1, 1, square root of 2. Do you have that one memorized? 45, 45, 90? If you don't, you need that one. You need both 45, 45, 90, and you need 30, 60, 90. These are things I need you to have down like the back of your hand. So if I say sine of 45, you can quickly draw this triangle. I don't expect you to snap off the answers 1 over root 2, boom. But I expect you to be able to write the triangle and then go, sine of 45. Sine is opposite over hypotenuse. I'm taking this 45 here, opposite over hypotenuse. So it's the 1 over the root 2. So I guess this is 1 over root 2 equals 2 over x. And then you should be able to solve that really easy. When there's an equal sign there, don't forget cross multiplying works. 1 times x is x equals 2 root 2. Cool, I found my answer. All right. I don't think you need to do every single problem in the homework, but I will tell you specifically which ones I want you to do and which ones I want you to skip. So I'm going to have you do with me problems 1 and 5 and 7, but we are going to skip 9. Okay, so everybody can cross off this one. I will give you a reasonable amount of homework, and then on the other side, I actually am going to grade it. So have it done tomorrow in class. So you are not, I know some teachers said do your homework, but then didn't grade it. I am not one of those people. I will grade it. I'm not saying every day, but we'll put it in the grade book a lot so that it counts, and that'll give you encouragement to actually get it done. But I also cut the assignment size down to make it reasonable to get it all done. On this one, I would say skip 25, but I need you to do one of them. This is the kind where you don't know, you only know the 90-degree angle. You don't know the other angles at all. And I'll help you with that kind in a moment. Last, I would like you to do this problem. I want to warn you, it's not drawn to scale. If this is truly a triangle that has 60 and 60 for these 2 angles, then how many degrees has that got to be right there? 60. It's not to scale, but it still can be done. You have to know that that is 60. And therefore, you can pretty quickly figure out how long these sides are, which then leads you to these sides. And don't try to figure it out twice. They're the same. All right. And that's the last one I need you to do. You can skip the rest of them on the page. Yes? The first one. That's what I mean. See? Right there. That one. That one. That one. Skip that one. Okay, I believe you. All right. So again, on this page, we're skipping 25, and then this is the last one I need you to do. Okay, I have one more thing I got to teach you, sadly. To be able to handle this one, you have to be able to do inverses. So for just a second, look at this. Let's say this is a 90-degree angle, and this is 2, and that's 5. Would you agree I can make a 90-degree triangle with those sides? And therefore, there must be some angles that would work. I don't know them. This isn't a nice one. It's not like one of the kind you memorize. So how would you do it? You'd say, I need to know this angle here. I call it theta. Notice me using theta instead of x or y. Write this down, please. You're going to need this example. It's a big one. So now, I know you've done this before, but you probably only did it once. You're going to have to use inverses to do this. So the way I would do it, I think the easiest way to do this is to go like this. Sine of the angle is opposite over hypotenuse, right? Which is 2 over 5. Are you with me so far? Then how do you undo? Okay, some of you are not writing. You need to write this down with me on your iPad now. All right, next, we need to get this sine off of there. Well, it's kind of like, what's the opposite of multiply? Divide. What's the opposite of square root? Squared. What's the opposite of sine? Inverse sine. It's not really the opposite, but it's what gets rid of sine, is this sign with a little -1. The -1 key on your calculator is not what you'd use. There's a special thing. Above your sine key, you'll see inverse sine. So if I do inverse sine, I have to do it to both sides, right? That makes this sine cancel this sine, and look, I've got theta alone. Theta is inverse sine of 2/5. So we'd use your calculator. You'd type in inverse sine, sine with a little -1, of 2/5, and the parentheses, hit enter, and find it for me right now. Could you repeat it, please? And that was what? Degrees? Inches? Number of chickens in Botswana? It's important to understand what you're doing. We're finding an angle, and it's degrees, and therefore that's that angle right there should be about 23 degrees. Seems reasonable. Anybody verify that? Okay, good. Yes? Why do we know the inverse? Well, you couldn't have gotten the answer of 23.578 without using inverse sine. Do you get, I didn't ever tell you how many degrees that was? To find how many degrees it is, you have to use an inverse. Yes? Good question. I am fine with you rounding to the first decimal place, like 23.6 in this case. 1 decimal place is fine. I'm pretty sure it says around to the 10th or 1 decimal place. Okay. Sorry that I had to run a little bit long today, but I had to introduce myself to the new people too. I usually won't run into your homework time this much. That's all I got for you for today.